So 2019 Leaving Cert Higher Level Paper 2 Question 4 is a trig identity. You're asked to show that cos 2 theta is equal to 1 minus 2 sine squared theta. So cos 2 theta is cos theta plus theta, and cos A plus B is equal to cos A cos B minus sine A sine B. So once you see these trig identities, you're going to go straight to the tables to find whatever you're going to replace. So we have on the left hand side, we've got the cos of 2 theta, the two of them added together. If we change the A and B's to theta, we get cos theta minus sine theta, and that's going to be cos squared theta minus sine squared theta. Jump back up to see what we're looking for. We're looking for it in terms of sine, this sine here. So we want to get rid of the cos. So cos squared theta, the most common trig identity that you'll need within these questions. Cos squared theta plus sine squared theta is equal to 1. So if we want to get rid of cos squared theta, we could replace it with 1 minus sine squared theta. That should help us in this question. So 1 minus sine squared theta minus sine squared theta is equal to 1 minus 2 sine squared theta, which is exactly what they were looking for. So this question solves quite quickly. The second part of this question, find the cosine, clue in the question, cosine of the acute angle between two diagonals of a cube. So we're going to use the cosine rule in this question. And the cosine rule states that a squared is equal to b squared plus c squared minus 2bc cos a. That's where the cosine will come in. So these are all to do with the sides. A is the side opposite the angle, so that's that side there. Now we have a cube, so let's call it x. So we need to get this length, and it's going to be the same as this length here. So how are we going to get these lengths? Well, the first thing we can do is, let me just change the color again. If I get this length over here, this diagonal, if I can get that diagonal and we have this side, I'll be able to get this third side all the way along here using Pythagoras. So hopefully you can follow that with all the colors. So to get the diagonal of one of the sides, if we have x and x, we can see that the diagonal is going to be the square root of x squared plus x squared, which is the square root of 2x squared. We can get the square root of both individually, the square root of 2 times x. That's what this bottom side in here will be. Now, if I draw that triangle out, that internal triangle with x, this x here on this side, and I can get this diagonal, it's going to be, we're going to use half of the length of this diagonal, which is going to be this bit in here that stops at the angle here. So we have the bottom bit, we have the square root of 2x. So the diagonal in this case is going to be the square root of x squared plus, well, root 2x to be squared is going to be root 2 squared and x squared, so 2x squared, which is the square root of 3x squared, which is equal to root 3 times x. So now I have this little diagram here. I have a triangle that looks like this, where this side is x, and the two internal parts of it are root 3x. And I'm going to use the cosine rule now to find this angle. So as I said, the a, I'll leave the formula there, the a is the side opposite, so x squared, sorry, this is not, we have to divide these by 2, we've taken half the length of the side. So we've got x squared is equal to root 3x over 2 to be squared, plus root 3x over 2 to be squared, minus twice root 3x over 2 by root 3x over 2 by the cos of A. Now hopefully this will simplify down for us. So let's see what we have. We have on the left x squared equals root 3x over 2 to be squared is going to be 3x squared over 4. Same for the next one. And then we have, well, those two will cancel. We have minus root 3x by root 3x, which is 3x squared over 2 by the cos of A. So I want to leave the cos of A on its own and bring everything else to the left. So let's simplify these two terms first. That's 3/4 plus 3/4 is 1.5, and we're bringing them to the left, so it's going to be 1 minus 1.5. So it's going to be x squared minus 1.5 x squared, and we're going to have to divide that. So we've moved these two things over, and we're going to have to divide by minus 1.5 x squared, which is this guy here with the sign included. So we now have that's equal to the cos of A. So what have we got on top? We've minus, well, the x squared, let's factor out those x squareds. X squared times 1 minus 1.5 over x squared by minus 1.5, and that will give us, that's the cos of A. So that turns out to be 1 minus 1.5, so minus 1 over 2, or minus 0.5 over minus 1.5, and that does work out. I should have probably kept, one's a fraction, one's a decimal, but you can see what I'm trying to do. So we're going to get 1 over 3. So it does simplify down nice and easy for us. The cos of A is 1 over 3. And I think we were just asked for the cos of the angle. We can get the angle as well, but what we were asked for the cosine of the acute angle. So we have our answer. What is A? The inverse cos of 1 over 3, and it's going to give me 70.52 degrees. So that's a nice question with a lot of algebra involved.